Hello, Math 1B. This is the fifth lesson of remote learning, and you will get a conclusion of polynomials, at least the review of it, where we will be multiplying it and then applying it to one kind of geometric application. So the first thing that you guys see up here is what happens when you've got 1, 2, 3 different polynomials being multiplied by one another. We only had 2 the previous assignment. Well, it's kind of like if you just think about multiplying 3 numbers together. So think about 2 times 5 times, I don't know, 3.5. If you were to multiply those 3 numbers together, then, I mean, my thinking is you can do one of 2 things. You can just go straight across left to right, so 2 times 5 is 10. And then when you multiply that by 3.5, that's just going to become 35. Or you can use the commutative property to say, you know what, I think I want to double something that ends in a 0.5 because those are usually easier to double than others. So doubling, or at least that gets rid of the decimal right away. 2 times 3.5 times 5. So then double 3.5 is 7, and 7 times 5 is 35. Bottom line, what I wanted to illustrate with those 2 situations is you have to just do one computation at a time. So 2 quantities multiplied together at a time. You can't just do all 3 at once. So you see, we had to do 2 times 5 first to get the 10, or we had to rearrange things and do the 2 times 3.5 first to get the 7. So all those things considered, let's just take the first 2 polynomials and multiply them together. The y plus 4 is just going to chill over here for the time being. And then it becomes a basic problem that you guys saw in the last lesson. So remember, you're taking all the pieces of the first term. So I'm actually going to rewrite this in red ink to show how this maps itself out. So a red y is going to be multiplied by 2y minus 3. Okay? Red y times all the parts in the second polynomial. And then this red negative 1 is going to be multiplied by, again, all the parts in the second polynomial. So then we get rid of the parentheses by multiplying the y through. That's going to be 2y to the second power. And this is going to be minus 3y. This is going to be negative 1 times 2y, negative 2y. And then a negative 1 times a negative 3 creates a positive 3. And at this point, we can simplify the 2 middle terms. They combine to a negative 5y. And you've successfully multiplied the first 2 parts of this product. All right, so this in a sense, what I just put in grouping symbols there is the 10. Okay, so if you were to say, I'm going to circle that puppy up and say I'm done, you would be wrong because we still got to take, like here, 10 times 3.5. We have to take our new polynomial times the one that was just chilling over here. So the y plus 4 now needs to basically find its way down here. And it's going to be multiplied by the first product that you got. So what I'm going to do is make some room over here. We're going to rewrite this in a place where we've got enough space to really deal with it. I'll get a different color here as well. Okay. It's a 3-term polynomial times a 2-term polynomial. You guys saw that in the last lesson. You just split it up in a very similar manner that you did the other. So 2y squared times y plus 4. negative 5y times y plus 4. And then a positive 3 times y plus 4. All right, let's distribute that. You know what? You should even pause this and try to distribute it on your own just to see if you've got the skills. So this will be 2y to the third, 8. Make sure that y squared's on there still. Negative 5, y times y would be y squared. Negative 5 times 4 is negative 20 with a y attached to it. And then plus 3y plus 12. All right, and then we can combine like terms. Luckily, the like terms are conveniently side by side with one another. So 8 minus 5 is a positive 3. And then same thing with these two. Negative 20 plus 3 is a negative 17. Y. And then the plus 12, there's nobody to combine with it, but it's going to be a part of the final polynomial anyway. So it's kind of a pain in the butt when you have to multiply more than two polynomials together. But as you can see, it can be done. It's just extending this idea of, can I split up the multiplication into manageable parts? All right, let's check the next one. All right, this one's even less, well, it's a little bit more intimidating. I see a third power right here. X minus 2 to the third power. So if you remember our lesson from the other day, a squared just means put two of those terms side by side. If it's to the third power now, you're going to write this 3 times. So ignoring the x plus 2, this is x minus 2 times x minus 2 times x minus 2. And then this x plus 2 gets dropped down here. Now, since after seeing that previous example, this can look very intimidating. However, we talked about the fact that, and you know what? I don't think I addressed this in the lesson yesterday. If you have two identical terms, one's positive and one's negative, you actually can do a shortcut. I'll show you what that looks like over here. If we were to work this out as normal, all right, x times x minus 2 plus 2 times x minus 2, you'll get the x squared, you'll get the minus 2x, plus 2x, and then minus 4. Notice these middle terms cancel each other out. That is the signature of this kind of multiplication. When you have, I call it good twin, bad twin, basically identical binomials, okay, that has to be a two-term polynomial, where you're separated by addition and subtraction, you can make that judgment of it's just the first times the first, and then the last times the last. It only works in those situations, though, where they're identical, and it's a good twin, bad twin situation. This is two bad twins side by side. All right, this is not going to yield x squared minus 4. All right? In fact, let's go off to the side and check out what x minus 2 times x minus 2 would be. Well, actually, you know what? I'm going to just take this work that I had and just make a few adjustments. So if this was x minus 2 times x minus 2, then that minus 2 just drops down here. It's going to be a negative 2x still, and then a minus 2x. Okay. Those middle terms do not cancel out when they are identical twins. When they're identical twin factors, x squared minus 4, and it actually always doubles what each part is. So that goes here. So I kind of did this in a haphazard way. Let's rewind. Coming back, we had 4 terms multiplied by one another. I highlighted the first 2 terms because they gave me something simple. They gave me a binomial. They gave me x squared minus 4. These, it just seemed like it would make more sense to multiply those 2 together next. That gave me x squared minus 4x. And you know what? I need to make one adjustment too, because we have a negative 2 times a negative 2 here, which is not negative 4. It's positive 4. Sorry about that. Which means this is positive 4. That's the polynomial that's going to go in parentheses here. And what we have now, and keep in mind, guys, this is still multiplication happening. I'm not just dropping the parentheses and saying, oh, I got an x squared and an x squared. That's 2x squared. That's not what's happening here. We still have to multiply both of these polynomials. So we got to get back in there. X squared first. X squared minus 4x plus 4 is my second whole group. Then we take the negative 4. That gets multiplied by everybody. And we do the normal thing. X squared times x squared is x to the 4. X squared times negative 4x is minus 4x to the 3rd power. Hopefully this is becoming routine, almost boring, dare I say. And then x squared times positive 4 is positive 4x squared. Alrighty, and then negative 4 times x squared. You're basically just changing the coefficients for each of these now. Negative 4x squared. Negative 4 times negative 4 is positive 16 with the x still. And then negative 4 times positive 4 is negative 16. Okay, can we simplify anything? Yeah, we got 4x squared minus 4x squared. That is 0x squared. Nothing else changes. And that is our final answer. I'm going to split this video up into 2 separate parts. There's only 5 problems for homework, but because it seems like these problems have so much depth to them, or at least they're time consuming, I'm probably just going to split this assignment over 2 days. So that's good news for you guys.